A functioning economy is a machine of perpetual motion, balancing millions of transactions every second, until, suddenly, the gears lock. Steady, theoretical output an economy achieves when it fully utilizes its technology, capital, and labor. But the actual economy rarely rests comfortably on that line. Real gross domestic product is volatile, oscillating above and below that potential trend line as it cycles through sudden booms and sharp recessions. The most severe recent example of this volatility began in December 2007, marking the start of the Great Recession. As the system slowed over the following 18 months, the human cost compounded. By June 2009, 7.8 million jobs in the United States had been eradicated. These jobs vanished because actual real GDP had deviated sharply and persistently below the economy's long-term potential. To understand why these severe deviations occur and how economists attempt to forecast them, we have to look past long-term theories of capital and technology. We must dissect the immediate, short-term mechanics of aggregate demand. A macroeconomic forecaster's primary task is predicting next year's real GDP, represented by the variable Y. To find Y, economists break total spending down into 4 specific flows: consumption, investment, government purchases, and net exports. Of these, consumption is the largest component, the critical baseline for any forecast. How consumers behave is mapped by the consumption function. This rule states a strict positive relationship between national income and consumer consumption. The catch: as income rises, consumption rises by a fractionally smaller amount. People save a portion of every new dollar. This creates a mechanical loop. Consumer spending relies on national income, but because GDP is exactly equal to national income, total income relies on spending. Because of this locked feedback loop, solving for next year's GDP requires us to build a precise geometric model to stack these variables together. This chart allows us to map that feedback loop. We plot total spending against total income, or real GDP. We place our foundational layer first. The upward-sloping consumption line anchors the graph. Next, we add the business sector, stacking total investment directly on top of consumption. We then add the public sector, stacking government purchases on top. Finally, we factor in net exports to complete the stack, giving us the total expenditure line. Notice the geometry. Because these layers are simply stacked, the entire line's slope is dictated by the underlying consumption function. This chart introduces the final tool for our forecast, the black 45-degree reference line. At every point along its path, planned spending equals actual income. The forecast is solved where our expenditure line crosses it, at point C. Economists call this intersection the point of spending balance. It isolates the exact level of real GDP where planned spending aligns with national income. Let's introduce an economic shock. Assume government spending is cut by exactly $100 billion. Geometrically, this immediately shifts the entire aggregate expenditure line straight down, establishing a new equilibrium at point D. But an economy is not static. That initial $100 billion cut in government spending directly reduces real GDP. Because real GDP measures national income, less GDP means there is now less total income flowing. Here, the consumption function activates. Confronted with lower total income, consumers are automatically forced to reduce their household spending. This secondary reduction in consumption acts as a fresh shock to the system, pulling real GDP down even further. That lower GDP again means lower income, triggering another drop in consumption. The cycle continues in a downward feedback loop. This cascading mechanism is the multiplier effect. Because of it, the final drop in real GDP is mathematically much larger than the initial cut. This chart translates our geometric cross into a calendar forecast. Normal expenditure naturally pulls actual GDP to its ideal potential at point C. But in 2007, an investment collapse dropped the expenditure line, trapping the economy at a lower balance, marked at point D. This state is a recessionary gap, where the spending balance forces actual GDP to fall short of potential GDP. Conversely, a positively shifted expenditure line forces actual GDP above its long-term potential, creating a temporary economic boom. The spending balance illustrates the initial short-run effects of demand shocks like the 2007 crash, but it has limits. Over the long term, different macroeconomic forces are required to pull a fractured economy back to full employment.